All right, so today I wanted to talk about gap buffers, the uses for them and kind of how they work, and then we'll go ahead and implement one. They're pretty easy to work with and probably what I would consider like the go-to for any small normal size text editor. If you think about just you have a continuous array, right? And you want to write into the array, right? So you have to, and because an array is just a fixed block of memory, if you want to write into it, you can really only write on the end. And if I need to insert one character in the middle, I need to take that entire array and move it somewhere else, right? And so every single insert, one after another, is always a full copy, right? You can't ever just write to the middle other than once, right? You do the one write, add a character, and they have to copy the whole array to a new place to actually patch it all back together. And so what a gap buffer does is it takes that array and it puts a hole in it. And so the let's just say like a 10, I don't know, 10 character array, just for something simple. You want to put something in at character 5. The gap buffer might be, let's say, 16 or 20 characters, right? It's actually bigger. So your data ends here, but the hole is at the end. So you want to put something in at the 5th character, you're actually going to move the hole to where character 5 is. And so what you do is you'll actually mem copy everything from character 5 to the end of where things are. You move them over to the end, and now you have some data, you have a hole, and then you have some more data. And this allows you to write lots of characters into that hole. And then anytime that you need to, or that you fill up the hole, there's nothing left, then you do reallocation. And so we're essentially, by setting it up this way, we're able to only do a periodic reallocation. And that gets us pretty close to like an O1 type behavior, right? It amortizes out. And so that's kind of what the gap buffer is and does. And let me show, let's switch here to this guy. And then let's show kind of what that looks like on, pictorially, I guess. So I just set up a raw file, if you will, right? So these 1, 2, 3, 4, 5, 6, 7, 8, 9, ABC, right? There's our file. And if the gap is sitting before the cursor, right? So here's my cursor, the little vertical pipe, and the gap sitting back here on, at 2 or after 2. So I've got a whole bunch of space in here, and I want to write exactly after the 2. And so what I need to do is I need to, from basically where the V squiggles are, I need to move these guys. So what is it, 3, 4, 5, 6, have to get mem copied from the right side of the array to the left side of the array. And so this is kind of your before state, and this becomes your after state. So now we've written, again, 3, 4, 5, 6 are pushed over on the left side. We can now write as much as we want, in this case, whatever that is, 7 or 8 characters, before we had to do a reallocation. The vice versa of that is if the cursor is before the gap, right? So I want to maybe do an insert at 3, or I guess at 3. It's hard to tell on the picture there. So if I wanted to do an insert at 3, I need to actually move 3, 4, 5, 6 over to the right-hand side. So again, we take 3, I've got this chunk here, and I can stick it over there. So now I'm back to kind of where I started in the beginning, right? And so then I can, again, go and do a whole bunch of writing. And so that's the central concept of a gap buffer, and they're dead simple. They work really well, and they're pretty easy to implement. So we're going to go ahead and do that. And so we'll just make a buffer position, right? And that's just going to be an alias to an integer. Then we'll make a gap buffer, and he's a struct. So a gap buffer is going to have a buffer in it, right? And so that's, it'll have, I think, a gap start and a gap end, I believe. These are basically the positions in the buffer. So I want to know, where does it start and where does it end? And then what we'll do next is, so we'll just stick him up there. Oops, that's not what I wanted. All right. And now the first thing we're going to do is make one. So we're going to make gap buffer. Oops. Oh my goodness. Can't type. So let's see, n bytes, right? So how many do we want to allocate? And then this is going to be an allocating function. So we'll say, which allocator do you want to use? We're going to do just the default allocator. And that's going to return us a gap buffer, right? And so then we'll just say B is a gap buffer, and we're going to return B, and we will just do buff equals make. Yeah, U8's fine. U8 of n bytes. And we'll just put the allocator here. Right, so we're allocating it, we're returning it, and we need to set the end. So we'll say gap end equals n bytes, right? And this makes sense, right? The start of the gap buffer is at 0 because it's empty, and the end of the gap buffer is at the end because it's empty. So now we can come up here and we'll say buff is make gap buffer 16, right? And that's, now we have a buffer. The next thing we're going to want to do, we need to shift the gap, right? And we're going to do, which is a gap buffer, and we need a cursor, which is a position. Next, we need to know how big is the gap, right? So we're going to say gap length is the buff dot gap end minus the buff dot gap start. We're going to guard for this exact scenario in right now where the buffer is empty. So what we want to do is say we want to take the minimum of the cursor and the len of buff dot buff if is equal to the gap dot start, which basically is like if it's empty. If the gap is after the cursor, and then we have the other scenario of else if g dot gap stick u there, right? And then we're going to say otherwise, basically else if the gap start is greater than the cursor. So let's move this guy up into here, and we'll move this guy down into there, and let's get rid of that one. We don't. Next, what we want to do is figure out how much do we need to move. The delta is the cursor minus the gap dot gap start. Nope, gap start. And then we're going to do, did I get mem? Got copy. Did I get mem? I did get mem. Okay. So then we're going to copy, I really want to call that B. There's a buffer. I guess we can call it B. B dot. Yeah. B dot buff at B dot gap start, right? And it's the pointer of. I think I need that. And then we want to go to the gap end by delta. Okay. And then we're going to say the buffer gap start plus equals delta, and oops, that was not right. Delta, and then the end is also going to advance, right? Because we're just taking, my gap has to move to the right, so both of them move to the right by that much, right? So that's that one. Now we want to do the other one, who's pretty similar. So we'll bring that down there. And in this one, it's going to be kind of the other way around, right? We're doing minus the cursor, and then we're going to go from the gap end minus the gap start. Oop. Start. Try that again. Oh, no. By delta. And then we're going to go the gap start by delta. Dot gap start by delta. And we're also going to do that. And then similarly, the pluses turn into, oops, minuses. that's really it. So now we're in position. In the reverse, right, we're going to say how much do we need to move, right? And that is essentially we're just taking where's the gap start and where's the cursor at. Then we want to take the destination, which is this guy, right, which is the end minus the delta. And then we want to grab basically from here, right, this chunk, and that's this pointer. And then we're going to, basically take those and just hop them over, right? So now they've jumped the gap. That is kind of the central procedure and really the entire gap buffer. So this is where all the brains, all the logic is. After that, you're essentially just making sure the gap is in place, and basically here we're early exiting if we don't need to do anything. And the other thing we need to do is make sure that there's enough room in the buffer. In fact, we're just going to snag you because I need the exact same field. So we're going to say, how much gap do I have, right? And if, and that's right. So we need to say n required. And this is, we want to check the gap size. And so if the gap length is less than the number required, right? So that means we're going to have to, we need to resize the array. And so then we'll do a shift gap 2. And I believe we're going to put it, so we're going to take length of the buffer by the end, right? So we're going to just scoot it as much as we can to the end. And then we'll just say new buff is we're going to go ahead and do a reallocation here. And oops, I really need to get like the little, like F and J have a bump on them. This is my keys don't, and I kind of lose my place quite a bit, and I don't know, really obnoxious. We're gonna go ahead and make a new buffer, and that'll accept the allocator. And then we want to copy the slice, and then that's going to be the new buff, and it's going to be b.buff, but I only want to take it, I want to take it from b dot till the end, right? I don't need anything past. What I want to do is I actually want to take the max here. Right, so it's either double the array or it's n required. And so I, just as a strategy, want to just double the array each time, but maybe they want to do a really big write, and so that might be larger than the doubling, especially if we start with like 10 bytes, right? And they want to put in like 1,000, right? This definitely won't catch it. So now that we've copied it, we need to, we're going to delete the original one on b.buff, right? So we don't want it anymore. And then we'll say b.buff equals new buff. And then b.gapEnd equals len b.buff. Essentially, all the good data is on the start, start to the middle, or to the gap start, really. And the gap start doesn't change at all during this whole procedure. All right? So now we have basically reallocate, right? So this is reallocation on gap to small, and this is gap mem copies, right? So those are kind of the two big procedures you need. This one's just a syntactic sugar, so nothing big there. Let's just do like insert character, right? And so that'll be a proc, and it's going to take in a buffer, buffer. And we'll just say a character, and he's a U8. When we do that, we want to check the gap size on the buffer, and I need 1 byte. And technically, all of these inserts, right? Because at any point, and this might be like a design improvement. Oops, that's not what I wanted. Maybe a design improvement is that the gap buffer actually holds the allocator. So when you make it, In fact, let's just do that, right? So we're going to say allocator. We'll just do this core.runtime, and we'll grab you and stick you there. And so now we have an allocator, right? So we can now make this guy, and we want to definitely assign it. So allocator equals allocator, right? That way, we're going to just take out all these external allocators. It does all of its own allocations on its own internal allocator. So it means b dot, right? Uses internal allocator. First, we check the gap size. We make sure it's big enough. Next, we're going to shift the gap. So we're going to move it and, oh, we need to know where we're going to shift it, right? Buffer position. And so we're going to shift it to the cursor. Once we've got it put into position, we're going to just write to it. So we're going to b.buff of b.gapStart equals, right, the character. And we'll say b.gapStart plus equals 1. There we go. So there is insert character. Next, we'll do insert rune. And identical here. The one difference is, right, we're going to put in a rune. So insert a rune. We need to actually encode the rune. So let's, yeah, because we need that. Bytes len is utf8 dot encode rune is rune r. And then now we know, let's not use that one, so it'll override the built-in. I don't think we're using it, but whatever. We know how big it needs to be. Pause for a second here. What we need to do, next we need to do a slice, right? So we're going to do insert slice. And that's a proc that takes in a buffer, a gap buffer, and a cursor position, and a rune. No, and a slice, which is going to be a 8. And so then same deal, right? If you want to run slice, and then shift gap to, oh, buffer position. So now we can do copy slice. We're going to do b.buff at, oh geez, I already lost my thought. What was this guy, the raw pointer? No, he's an array. So we're going to do b.buff at b.gapStart. Take that, go away. And then we'll take the slice and we'll go ahead and do that. Now b.gapStart plus equals the len of the slice, and then we can come back to you and we can do insert slice. In fact, let's save a few operations there and not even do that, right? Because we're going to do it in insert slice. So now we can do b cursor, and then it's going to be bytes. And what I thought you came back as that? A 4u8. Oh. Okay. So now we're doing insert characters, insert runes, and insert slices. We probably want to do insert string. You can see this is a pretty much just rote at this point, right? So there's a string. You could almost do it this way. This is like a convenience function. So all we'll do is cast that over to a U8, and then we just insert it. It seems like that's the majority of our inserts, and let's make it a little nicer, right? And so we'll do insert char, insert rune, insert slice, insert string. I'm going to do remove just because I don't want to collide with the built-in delete, and I don't want to have some goofy prefix. So we'll say gap buffer, and then where is a buffer position, and count, right? So we do shift gap 2, right? And then we're going to move it to the cursor. Yeah, I think I just take the length off the tail. Pretty sure. So I just move the gap and then nix the tail. Right, so that would just be b dot gap end plus equals count. We'll just do equals the min of that guy, right? And the len of b dot buff. That way we don't accidentally run off the end. So if I set it at 0 and I want to delete 3, right? It's oops, you know what I mean? Close enough. What else we need? Look at this as if it was a contiguous string. And that's... I'm trying to think how you do that without cloning it. Because if your gap is in the middle, right, a string needs a continuous array, and you're just not going to get that. Let's defer that for a second. Let's go do a little playing. I went ahead and clipped most of the rest of the video. I was just debugging the 2 bugs that I put on little annotations on the screen for you, and so there wasn't really any reason to show that. This is just kind of a final closeout on what do we have. So I can make a buffer. In this case, I make it with 2 characters. We can unlock these guys real quick, and maybe we'll just comment out. Oops, that'll be fine. Comment out these for a second. We'll insert a character. We insert another character, right? So these are 2 sequential inserts. Now the buffer is going to be full. We'll then do an insert where we put in a bunch of stuff, and then we'll stick an A at the beginning. Right? Let's go ahead and run that. Odin run dot. We got our A at the beginning. We have the space is because there's a left and right string. Yeah, I didn't mention that. While I was debugging, I put together a little helper function. I can look at what's the left string, which is everything up to the gap start, and what's the right string, which is everything after the gap start. This is kind of a handy way to not have to mess with all of the logic. I don't want to do it right now, but we probably want to build on top of this and say like get it position. So I want to take and wrap this on I want to take the cursor and a length and go find the composite string of those 2. Looking at this one, this was just testing out remove. Oh, I guess I need to not delete the gap buffer. So now we're going to just insert, 1, 2, notice I skipped the 3, 4, 5, 6, 7, 8, 9. Then I put the 3 in at the correct position. And I was doing this to put the gap in the middle just to make sure that the remove had to do its job. And then we're going to take and delete indices 1 to 8. We'll go ahead and run that. And prior, right? So we have 1, 2, 3, or 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're left with 0 and 9 after we do the removal. That's essentially the gap buffer. Everything, you've got 3 major operations: insert, remove, and kind of a get, which like say we'll get that one later. It's a super simple build on top of this function right here. And that's it. So we'll call it done.